In this video, let us continue to solve problems based on trigonometric identities. So we've got a problem which here reads, prove that 1 plus cot theta minus cosecant theta into 1 plus tan theta plus secant theta equals 2. This is what we have to prove. So what we'll first do is start off with this, just write 1 as 1 itself, and then write cot theta as a ratio of cos theta and sine theta, because that is what is, this is the reciprocal of tan theta, right? So tan theta equals sine theta divided by cos theta, and cot theta equals 1 by tan theta. So 1 by tan theta is nothing but the reciprocal of the tan theta, so which is nothing but cos theta by sine theta. So that is where I've written cot theta as cos theta divided by sine theta, and minus cosecant theta. Now, what do you write cosecant theta as? You'll write it as 1 by sine theta. Basically, what we're trying to do is break these down into sine and cos, and yeah, that's what we are trying to do, because we cannot kind of multiply this. That's another way of approaching it, but you can definitely do that and try if you get to, but it's all more of a trial and error basis. That's how we solve these, but with practice you know what you have to do exactly with some problems. So this is the first step, as far as this part is concerned. In the next part you write 1 as it is, and then you write tan in terms of sine and cos, so sine theta by cos theta, and then secant theta, you write it as secant theta is nothing but 1 by cos theta, right? Cosecant is 1 by sine, so secant is 1 by cos. So this is what we have, the left hand side. So now just work these things out inside, take LCM and all those things. Here you can see that the LCM is sine theta, definitely. So make this a fraction, and then this becomes 1 into sine theta. So this also becomes 1 into sine theta. That's the rule of LCM, which I'm not going to go into right now. So if you've got any doubts about that, kindly check into the previous videos where I've explained about LCM. So here we've got the numerator is sine theta plus cos theta minus 1 divided by the LCM is sine theta, into, we've got the LCM here is cos theta, so it'll be cos theta plus sine theta plus 1. And now what we can do is, if you can clearly see that sine theta and cos theta considered as one term, and again sine theta cos theta it's the same, it's just rearranged. So this is one term. If you see this term, it is a minus b into a plus b, which is a square minus b square, right? So on that basis this becomes sine theta plus cos theta the whole square, that is the a square, minus b square, which is 1 square, and that is 1, divided by sine theta cos theta. You multiply the top and the down as well, so the numerator and the denominator as well. So sine theta into cos theta is what it becomes. And now just expand this, you get this is of the form a plus b the whole square, right? So it'll be sine square theta plus cos square theta plus 2 sine theta cos theta minus 1 divided by sine theta cos theta. So now we know that sine square theta plus cos square theta equals 1, right? So 1 plus 2 sine theta cos theta minus 1 divided by sine theta cos theta. The 1 and the negative 1 gets cancelled, and you're left with just this. 2 sine theta cos theta divided by sine theta cos theta, and then you just cancel sine theta cos theta, and you're left with just 2. So we've started off with the left hand side and we've arrived at the right hand side. So all that you have to do is just break these down into their simpler things. Cot theta can be written as cos and sine. So try and get them in terms of sine and cos, or mostly there are 2 brackets here, try and make them the same. If you noticed here, it's all, there's nothing else except then sine and cos, right? So but in different forms, of course. You do this, eventually you're going to end up at 2. What I'd suggest you to do is just try multiplying these straight away and see what you end up getting. 1 times 1 is 1, and then 1 times tan theta is just tan theta, and then 1 times sec is just sec, and then cot into 1 is cot into tan. Cot into tan is going to be just one, because both of them are like reciprocals of each other. So the multiplication of reciprocals of each other is going to be 1. So you may end up something, you may not get the answer, but you'll know what not to do as far as a given problem from trigonometric identity is concerned. That's how the whole trigonometry works. It's all mostly trial and error basis. There's no hard fast rule to anything. So that's one important thing that I'd like you to remember. Otherwise, this problem is pretty much done. A very simple problem. So that concludes this video. I'll see you in the forthcoming videos with more problems based on trigonometric identities.